One.
All right, hello. So in this video, I wanted you all to see why it's important for us to use our logarithms and exponential functions or equations and understand why they are developed, okay? So go ahead and title this, oh, that's pretty big. Okay, hold on. Go ahead and title your notes as 4.15, and it's called Why Were Logarithms Developed? Okay, so for our next class, what we're going to really focus on is applying our log and exponential rules in order to work with a word problem. Okay, so right here in your notebook, you can call this is the main title, and this can be your subtitle. Looking at more realistic problems. So here we have the cold virus is passing through a school. A doctor takes a culture and is studying the growth of a population of bacteria. At the beginning of the study, there are 200 bacteria. She notices that the population is tripling every hour. The scientists recorded the following information in her notebook, but she forgot to label each row. Label each row to show that what quantities, including appropriate units, are represented by the numbers in the table, and then complete the table. Okay, so we have a lot of stuff that we have to do. So we have to label each row, and then here it says define the formula for the population of bacteria, P of T. Okay, so we have to find a formula, and then use the formula to determine when the population of bacteria will be at 100,000 bacteria. All right, so we got a lot of stuff to do. But in your notebook, since you're not going to copy this whole entire word problem, let's just copy some key things. So I would say that this is what's given. So in your notebook, this is how you would annotate from your computer to your paper. So I would say what's given to us. From here, we know that there are 200 bacteria. So what's given is at the beginning of the study, right? So we can say at beginning, there is 200 bacteria. Also, we know that the population, so the population is tripling every hour. So we can also say population increases by tripling every hour. Okay, so that's all we know. And then what we need to do first is go ahead and label each row to show what quantities, including appropriate units, are represented by the numbers in the table, and then complete the table. Okay, so right here, this is the first step. So in your notebook, after you've written down the givens, go ahead and copy this chart as best as you can in your notebook, like so. I'm just going to highlight it so you can kind of see what I'm requiring you to copy down. Okay, so what we have here is that we have 0, 1, 2, 3, 4, and then 200, 600, 1800, and some blank spots. So this tells me, since there is at the beginning 200 bacteria, this probably represents the population. So, or the number of bacteria. So I'm going to go ahead and label this section here, population. Oh, that's pretty bad. Let's get a different color here. So right here, population of bacteria. And it's telling me to also include appropriate units. So this could probably, they already said population in the next problem, population of bacteria as P of T. So I'm going to call this P of T. Okay, so I know that represents the populations, and I'm comparing the population in terms of hours. So what I can say here on top is time, but in hours. Okay, so it triples every hour. So at 0 hours, it's at 200. Okay, and then at 1 hour, so it's tripling, so it's times 3. I get 600. And then here, it triples again, times 3. I get 800. Triples one more time. 1800 times 3 should give me 5400. And then I would want to go ahead and triple this value, and I will get 16200. Okay. So we did the first step. We labeled each row, showed the quantities, and we completed the table. Now we have to do number 2. So number 2 is saying for us to define the formula of the population bacteria. So in your notebook, after you have your chart, you want to go ahead and write down this right here. It says define the formula for the population of bacteria. So how are we going to create a formula, right? So if you remember way back when, we talked about, I can put this on the side, we talked about how to create an exponential. And I said here you normally have, I think it was something where, I think I had it where it's a times b to the x is equal to y, or a function. And so a represents your initial value. B represents the rate that it's changing, so it's also represented as the base. And then here, this represents the time interval. Time interval. Okay, so then here, if this is our A represents our initial value, so when at 0 hours, the number of bacteria that's in the culture is 200. So I know for this case, my A value is going to be 200 times the base here, which is how it's increasing. So it's tripling, therefore my base is going to be 3. And then the time interval is every hour. So in every hour, it's just going to be represented as an x. And it's going to set equal to the population of bacteria, P of T. Okay? So now that we've done that, that's our formula, we're going to go ahead and do number 3, which says use the formula to determine when the population of bacteria will be at 100,000 bacteria. Okay, so this time they gave us the P of T. So I'm going to show this work right here. So I know this is kind of messy, but you should have in order in your notebook the givens, the table, number 2, and then we're at number 3. Okay, so the formula, I'm going to rewrite it one more time. So the formula is P of T is equal to 200 times 3 to the x power. And we know the population that we want to figure out. We want to determine at what when, right? So what hour will it be when there will be 100,000 bacteria in our culture? So we're going to set P of T equal to 100,000. Okay. So that way we can find out at what hour will it be when it's exactly 100,000 bacteria. So look, this looks like an exponential equation. So we're going to go ahead and do our first moves here. So we're going to divide by 200 first, and that's going to get the 3 to the x power by itself. And when you divide this, we will get 500. Okay, well, this is where I told you all that if you can get the same base, we are able to solve for our exponent. 503, however, do not share the same base. Therefore, we have to take the log of both sides. So that's where we're going to log both sides here. So I'm going to take the log of 500 is equal to log of 3 to the x power. All right, so at that point, what we can do is I can move this exponent in front of the log and multiply it, right? So the new thing should look like this, or a new equation should look like this, where I have x times log of 3. And then from there, I would want to go ahead and isolate x. So I can isolate x by dividing by log of 3 of both sides, or I can also simplify this 500. So I'm going to do that first, actually. So this log 500 is going to become 5 times 100, and then that will, if I want to expand this, I'll get log of 5 plus log of 100, which is the same thing as log 10 to the second power, equal to x log of 3. Okay, and then at this point, I know that log of 5 is just going to stay the same. And log 10 to the second is just 2, equal to x times log of 3. Okay, now at this point, I can go ahead and divide log of 3 now that I simplified the left side. So I can divide by log of 3. Log of 3 divided by log of 3 will cancel out and give me 1. So then this will equal to log of 5 plus 2 divided by log of 3 equals x. Now, if I had said there was no calculators used on this document, then your answer would be like this. And you can leave it like this and say, well, this represents the hours. But since we do, but if I want to find the actual hours, you can use a calculator and do log of 5 plus 2. So when you do that, log of 5 plus 2, when you punch that into the calculator, you're going to get a decimal up here. You're going to get like 2.69897. Let's just keep it like that for right now. And log of 3 is 0.47712. And when I divide those two values together, I should get, let's see, log of 5 plus 2, divide that by log of 3. I should get 5.65678. So about that much if I'm going to round. So those are the wavy lines. So this just means that at about a little over 5 hours, this population will be at 100, or the 100 will be at 100, the population will be at 100,000 bacteria. So what I can say here is that when x is about 5.65 hours, the population will be at 100,000 bacteria. Okay. And oops, that will be my answer. So essentially what you are doing in this problem is to see why logarithms were developed, right? So it was very hard for us to calculate the hours in its exponential form. But when we were able to apply our log properties, we are able to solve and find that value, okay? So that was a little over the next hour and or so in determining when the bacteria will be about 100,000, right? So it just increased exponentially, but we needed to find the hours using our logs. Okay, so I understand that this may have been a little confusing or pause, rewind, or and view the video one more time if you have any questions. But go ahead and write down your summary here, any key things that stood out to you, and any questions as well. And bring those ready for class, because this is what we're going to be talking about. All right, that's it. Bye.